Hi, everybody. So last week we spent our time finding rates of change from different representations for linear, quadratic, and exponential. And that was to help us as we come into, we're going to start comparing functions. Today we're only going to compare a line to a line. So let's kind of do a quick review. Over the course of the year, we've talked about different representations of lines. We had slope-intercept form, which we often see y equals mx plus b. Our standard form, ax plus by equals c, and then we had our sequences, which were also lines if we had graphed them. It was just a different way of writing the equation. When we're going to compare our lines, the most important things that we usually look at is we want to look at slope, x-intercept, and the y-intercept. Slope, remember we just did last week, y minus y over x minus x, the change in y over the change of x. The x-intercepts, it's where the graph crosses or touches the x-axis, and the y value there is always 0. The y-intercept, where the graph crosses or touches the y-axis, and the x value there is always 0. And an important thing to remember is when we're comparing our rates of change, you want to look at the absolute value of the rate of change and not a sign. So say we had a rate of change of 1/2, and we had a rate of change of -2, and I wanted to compare them. Really, I want to look at the absolute value. We've done this before. The absolute value of 1/2 is 1/2. The absolute value of -2 is 2. Now I can do a relative relationship between them. How does 1/2 compare to 2? 1/2 is less than 2. So if I asked a question, which rate of change is greater? You could say, oh, well, the 2 is greater because this is going to be a steeper line than this. And that's really what a comparison on the rate of change is asking. So let's kind of give some examples here so you can see. So I have two lines on this graph. I have this line named f of x. I have this line named g of x. And so I'm going to use f of x and g of x throughout this. It's just different ways of naming them. I could have called this Fred and Ginger. It's just so you know which function I'm talking about. All right, so my question, I have two questions going in my example here. The first question is, which linear function has a greater y-intercept? So the y-intercept is where the graph crosses or touches the y-axis. So there or there. Which one has the bigger numbers? What this question is asking. So that's this line, and that line is f of x. Okay, because we could look at it, we have a y-intercept of 5, and we have a y-intercept of -3, and 5 is greater than -3, so f of x is the greater one. Which linear function has a lesser x-intercept? Okay, x-intercept is on the x-axis. Here's our two values. One of them looks to be -1.75, I'm kind of guessing here. And the other one is 1 to -3. How do these compare? Well, -1.75 is actually more positive than -3. So it's bigger than -3. It's a bigger number. Now our question is, which one's lesser? The -3, and the -3 belongs to g of x. All right. Now, that's when we're looking at our graphs. Let's look at some table of values. My first question is, which has a greater rate of change? Remember, rate of change is slope. So these are lines, and I told you that ahead of time. So we can do a little bit of a cheat method here because these are lines. I know no matter what 2 points I pick, I'm going to get the same number because a line has a constant rate of change. On a table, another shortcut, remember, rate of change is y's over x's. So if I look at the change in the y's, this is -2, -2, -2, -2 each time. This is +1 each time. I'm going to put the y's over the x's and go -2 over 1, which gives me -2, the absolute value of which is just 2. Okay, because I'm going to compare it to this guy. What's happening in this? How are the x's changing? They're adding 1 each time. So this is going to be over 1. How are the y values changing? -2 to 3 is +5. 3 to 8 is plus 5. 8 to 13 is plus 5. Okay, so I get 5 over 1, or just 5. The absolute value is 5. This is how they compare. 2 is less than 5. My question is, who has the greater rate of change? The 5 does, and that is from g of x. Okay. How about my y-intercept? Now remember, y-intercept is where the graph crosses or touches the y-axis. Your x value there is always 0. So when I look at this table of values, here's where x is 0. So my y-intercept is 8. But when I look at this table of values, there's no 0 here. But if I follow the pattern, 5, 4, 3, 2, 1, 0 would be the next one in line. So I can follow the pattern on my y values too. What are they doing? 2 to 4, 4 to 6, 6 to 8. I'm adding 2 because I was subtracting 2 going down. So I'm adding 2 going up. So the next number would be 12. So that y-intercept will be at 12. 12 is greater than 8. My question is, who has the greater y-intercept? Well, 12 does, and that belongs to f of x. Okay? All right, let's take a look at the back. Remember, you can always go back and look at all of these at your own leisure. Okay, so we're going to determine which function has a greater initial value. So the initial value is your y-intercept. It's where you begin, and that tends to come in, especially when we're having some real-world questions. And then we'll also answer which function has a slower rate of change. So in our word problem, it says a car begins a road trip 50 miles from home. 50 miles from home is where they're beginning. So they're beginning at 50. This equation, we have mx plus b. B is the y-intercept. That's where you're going to begin. So their beginning point is at 55. 50 is less than 55. What is our question? Our question is, who has a greater initial value? Well, 55 does, and 55 belongs to g of x. So g of x has the greater initial value. Now let's look at our rate of change on these same problems. So our car begins his road trip 50 miles from home and travels at a rate of 60 miles per hour. So this is his rate of change is 60. That's how much he's changing every hour. Here's my slope in this slope-intercept form, which is 45. 60 is greater than 45. And we want to know who has the slower rate of change. That's the 45 value, so that belongs to g of x. All right, another example. Which linear function has the smallest rate of change? Let's just deal with rate of change right now. Now, both of these are in slope-intercept form, so I can just look straight at, I got 3/4, and I've got -2. Both of these are my slopes right here. So remember, you want to look at the absolute value. So the absolute value of 3/4 is 3/4. The absolute value of -2 is 2. 3/4 is less than 2. And I want to know who has the smaller rate of change. Well, that's the 3/4, which belongs to f of x. All right, now our y-intercepts. We are in slope-intercept form, so this second number, that's our b value, that is our y-intercept. We have 8, we have -1. 8 is greater than -1. And our question is, who has a smaller y-intercept? So -1 is smaller. That belongs to g of x. So g of x has a smaller y-intercept. All right. Now, these two, I recommend stop the video, try them completely on your own, and then come back and check. All right. So let's take a look. Who has the greater rate of change? So I have a table of values. I know these are linear, so I can do the cheat methods. Otherwise, I'd probably give you 2 points to start with. So on my x's are increasing by 3. And my y's are increasing by 2. So this slope is 2 over 3. And here's this slope of 1/2. So I have 2/3 and I have 1/2. Remember, we're taking the absolute value of each. That doesn't change anything in this situation. And how do these compare to each other? 2/3 is greater than 1/2. Now, who has the greater rate of change is what the question asks. 2/3 is greater. That belongs to f of x. So f of x has the greater rate of change. All right, and our last question, who has the smaller y-intercept? So in my table of values, remember y-intercept is where x is 0, so that occurs right there. So the y-intercept for that one is 15. The y-intercept for this guy is right there, 7. 15 is greater than 7. Who's smaller? 7 is smaller, so that belongs to g of x. G of x has the smaller rate of change. All right, so that's all I'm going to have you do for today is complete these notes. For tomorrow, we got practice, and then we'll do a quick check on Wednesday. Please let me know if you have any questions. Have a great day.